Hello viewer, welcome to our chemistry lesson. Now today we are in lesson 9 and we like to continue in our lessons. But amidst this coronavirus pandemic, we would like to remind you that continue staying at home, continue obeying the guidelines given by the government, but we are going to be safe by that. Now it is actually said that there is no country in this world that it doesn't have rules and regulations. Therefore, it is good to follow the rules and regulations of the government, but we actually keep ourselves safe. Remember, these rules are actually going to make us to come back to school very soon. So we want you to be engaged in this presentation that we are actually presenting. I hope you are going to tell your friend that we have lessons in chemistry. We are going on in our YouTube channel called Mwalimu Sitonik. Thank you and welcome to our lessons. Now, today we want to actually look further on our presentation on electrochemistry. This has been our lessons that we have been carrying out. This is a topic in Form 4 called electrochemistry. Now, in our today's presentation, we are going to pick from where we stopped the other time. Remember, we have been looking at the standard electron potential. Today, we want to look at what we call the primary and the secondary chemical cells. The primary and the secondary chemical cell. And in primary chemical cells, we are going to look at just one example in each. So we are going to look at one example in primary, one example in secondary chemical cell. Remember, these chemical cells actually, these are reactions which are actually producing electricity. Now, remember, electricity is actually produced here by chemical means, not just like the one which you have as hydroelectric power, whereby electricity is actually produced by the electromagnetic fields. This here purely deals with chemical reaction. So you see how important this topic is, that we are studying something which is actually going to give us energy, which actually we can use in our homes to actually maybe run several projects and maybe give us light and maybe enable us to actually operate our electrical devices. Now, so the objective of this lesson is actually to describe the functioning of the primary and the secondary chemical cells. So we are actually should be able to describe the functioning of that. Remember, here is actually we are focusing on the functioning. Now, I want to remind you that the redox reaction in an electrochemical cell is the one which actually is commercially applied to make the dry cell and lead acid accumulators. So somebody here took a concept here. There are people who actually take advantage of what actually they have learned. So somebody took advantage of this and modified the knowledge actually learned from electrochemistry in designing dry cell, and somebody else took advantage in designing the lead acid accumulator. And the two of them are very important in running the devices that we have. So that's why we should study. So let's start with what we call the dry cell. Dry cell. You know, when we talk about dry cell, we are not talking about anything else. We are talking about the normal battery that we have. Now, so this normal battery that we have, maybe I can actually show you an example of that battery. So we have here an example here. We have it as a dry cell. This is a dry cell. So this is our dry cell. This is our dry cell. So this is now which one we are, the one we are going to study. But I want you, during your own free time, as we are going to study, we are going to see, take a look at that. Just break one and see the components of that. So maybe we are going to start now looking at this, whereby we are saying that the dry cell consists of, now these are the components of dry cell, consists of a zinc can containing a graphite rod at the center, surrounded by a paste of ammonium chloride and zinc chloride. So we have two chlorides here. We have ammonium and zinc chloride here. So remember, this actually has their function. So we have a zinc can. So we have a zinc can. Zinc can here is the outer part here. All of this is actually zinc can. Now this one actually has a function. Then we have inside here, we have a rod, just like this one is protruding. That means we have a rod here. This is actually a cap. This is a cap of that. Now, then we also have, in addition to that, we have powdered manganese 4 oxide mixed with carbon. So this actually a black substance. This is a black substance, don't forget about that. It's a black substance. So we have here a mixture of manganese peroxide and carbon. Now, in this case, the zinc here acts as the negative terminal, where actually it ionizes or dissociates. So this is where ionization is initiated. So this is actually a negative terminal. Electrons here are produced. This one ionizes, produce here zinc ions plus 2 electrons. So actually that acts as a negative terminal. So we have here the zinc gun is acting as a negative terminal. And therefore, it generates electrons in that case. So it ionizes to generate electrons. Number 2, we are saying that we have this diagram now. We have this diagram. So we have here brass alloy cup. This is a cup. This is a lid. Okay. Then we have the ceiling. So we have the ceiling here. The ceiling is actually something like a cam inside there, round, something like a cam. I think the first layer there. The first layer, when you break this, you get actually the ceiling material. Now, but another one also we have here the carbon rod. We have the carbon rod here, which is black, so you cannot actually confuse that. Then we have the powdered carbon and manganese oxide. So you cannot also confuse that because I have told you this is actually a black substance. Then, if you are very careful, you will actually see a thin layer here. This thin layer is which is actually something like a colorless solid. It's like a jelly. It's like a jelly. If you have a normal jelly like the one we are using, the normal jelly is here. Okay, the common ones. The common one, like just like the Aramis we are using. I think it's actually just like that. It's actually almost colorless. So we are saying that one actually is a mixture of ammonium chloride and zinc chloride. Maybe we have, and then we have here the zinc can here. This is the other part is actually where you have zinc can, which is a negative electron. So this one here, the carbon rod is actually the positive terminal. It's actually the positive terminal. Now let's look at what's happening there. Let's look at what is happening. The ammonium ions in the ammonium chloride serve as the positive terminal. Where it's actually converted into ammonia gas and hydrogen gas. So if you have ammonium ion, it is converted to ammonia gas and hydrogen gas. Now this is the equation. We have the ammonium ion. It gains the 2 electrons lost by zinc to become actually ammonia gas plus plus actually hydrogen gas plus hydrogen gas. Number two, that is actually the reaction on the positive terminal. We are seeing ammonia form a complex salt with actually zinc ions which form as a complex called tetraamine zinc 2 ion complex with actually zinc chloride. Now the zinc chloride here is actually forming the complex in the paste. Therefore, why do we form the paste there? Why do we form a complex there? To actually reduce the accumulation of ammonia gas. Now we are seeing manganese oxide here oxidizes the hydrogen produced. Remember, hydrogen produced there will accumulate on the positive terminal, and therefore will actually prevent the flow of electrons. So therefore, this one has to be, the hydrogen gas produced has to be oxidized. And which is the oxidizing agent there? It is manganese oxide, which is oxidizing the hydrogen gas produced to water. It's actually oxidizing hydrogen gas to water, and therefore it's actually renders that to be safe. That is why after some time you will feel the cell to be actually soft. The cell will be soft. Why? Because we have accumulation of water. Accumulation of water. Now, ammonium chloride is actually used as a paste because the solid does not actually conduct electricity. In form 2, you say that we have the ions which conduct electricity. So ammonium chloride here is a paste whereby it's not, the ions now are actually mobile, and therefore if we have the ions are not mobile, the reaction actually the electricity cannot be conducted because they are not mobile. But this one, it is now paste, and therefore the ions are mobile. They can conduct electricity. That's like what you learn in Form 2. Now, since the reactants are used up, so remember here reactants are used up. So the reactants are not actually replaced. They are used up. The dry cell cannot provide continuous supply of electricity. So that is the disadvantage of the dry cell. It is actually the reactants are used up and actually cannot be replaced. And therefore, it cannot actually supply continuous supply of electricity. It cannot be continuous. After some time, actually, gets depleted. Now, therefore, you should actually, from this information here, it's actually evident that this cell here is not rechargeable. So it's actually non-rechargeable. It's non-rechargeable. But the dry cell is non-rechargeable. So therefore, somebody thought of coming up with something which is actually recharged. Now, what is that? This leads us to what you call the lead acid accumulator. What is this lead acid accumulator? It is the normal battery that you use, even in cars, even at home, and others. So that is lead acid accumulators. This is what we call the secondary accumulators are rechargeable, and unlike what primary cells or electrolytic cells, whereby this one is made of the lead plates. As the name suggests, it's actually made of lead. So lead plates that forms the negative terminal. Lead plates that form the negative terminal. Later on, we are going to see the diagram. Then we have the lead peroxide, which actually forms the positive terminal. Lead peroxide, not lead oxide. It is lead 4 oxide. Now, so this forms the positive terminal. The other one forms the negative terminal. It is actually very easy for you. Then the two electrodes are dipped in concentrated sulfuric acid. Now this one now is not actually the original one. The concentration here should be around 1.2 or 1.3. 1.2, 1.3. That's why normally we refill the lead acid accumulator with water. Not the hard water, but the still water. The one which ions have been removed. There's a reason why we have that. Now, at the negative terminal, lead ions dissolve. We have the negative terminal now. We have the lead. Lead now dissolves. When it dissolves, it gives 2 electrons in this equation. So we have lead dissolved to give 2 electrons, and lead ions. Lead ions. Lead 2 ions. Then at the positive terminal, now we have now this equation like this. We have now lead 4 oxide reacts with hydrogen ions in sulfuric acid. Remember, lead 4 oxide here is actually acting as a base. So lead 4 oxide acting as a base. Therefore, it reacts with hydrogen ions to form lead ions plus water there. So we have lead 4 oxide plus 4 moles of hydrogen ions, which come from sulfuric acid, plus 2 electrons to give us lead ions plus water. So the moles of water here will be 2. The moles of water there will be 2. So you actually have to put 2 there to actually acquire the balanced chemical equation. Now, having said that, let us try to look at this component. Now, if you actually happen to break this, lead acid accumulator, we have some plates which are arranged. We have those which are actually positive, and we have those which are negative. So the positive electrons, we have lead 4 oxide. These are the lead 4 oxide. They are soft in nature. Then we have now the negative electrons, which are now in between that. We have what? We have the lead metal there. So it's actually composed of lead. Then the 2 of them are arranged such that now in the layers, we arrange in layers, which actually will supply some electricity. Then of course inside that, inside this strong lasting material, we have dilute sulfuric acid. So maybe you can actually have an amplified one here, whereby we have here negative terminal. Negative terminal here is the one which actually has lead. So you see, it's actually connected to lead. All of these are actually lead. All of them are lead. So we have several cells here. 1, 2, 3, 4. This one has actually around 4 cells. And then we have the positive terminals here. The positive terminal then actually has the lead 4 oxide. So that's actually an amplification of that. Maybe during your own free time, you can still look if you can get one. You can look at that. So, but I want to say this: the lead ions actually form instantly, react with sulfates ions. Remember, in form 2, we said all sulfates are soluble except we have lead sulfate, we have calcium sulfate, which is very insoluble, and we have barium, which is actually also insoluble. So we have lead here, which is formed here, is what? Insoluble, and therefore it is actually for you to know that if you are forming an insoluble sulfate. So after some time, the reaction will be equally slow. Why? Because we will have formed a lot of lead, insoluble lead 2 ions. We will have formed insoluble lead 2 ions. So in this case here, we have lead ions plus sulfate ion. It gives us lead sulfate. What is the state of that? It is solid. Why? Because we said in form 2 that all sulfate are soluble except barium, lead, and calcium, which is actually sparingly soluble. So all the three of them are actually insoluble. So one of them being lead is now insoluble. Now the overall cell reaction is called the discharge. So when you sum the two equations, the first equation and the second equation, so you are going to obtain this. So with this we have lead oxide, lead, and then we have lead which is equal as negative terminal. This is a positive terminal plus 4 electrons plus sulfate ions. It's going a discharge. Why? We are actually depleting the ions. We are depleting the what? The reactants here. So whereby we are going to actually obtain lead sulfate plus 2 moles of water. 2 moles of water. Therefore, at the end of this, we'll have here the concentration of sulfuric acid will have gone down because of addition of water. The insoluble lead 2 sulfate form should not be left for a longer since fine lead 2 sulfate will change to a course non-reversible. So this one actually should, that's why it's actually recharged. If the battery actually gets depleted, it is recharged. It should not take long. Why? Because it will form a course which is actually non-reversible and inactive form, making the cell less efficient. So you should actually recharge regularly. On regular basis, it should be recharged. As the battery discharges, lead and lead 4 ions are depleted, and the concentration of sulfuric acid actually decreases, as I have said. Now that's actually what we have. So during recharging, the electrode reactions is reversed as below. So this is actually if this is discharging. Now if you want to recharge, you write from this other side. So that's why you write from this other side. So you see this recharging equation is just a reverse of this. So start from the left hand side, right hand side, and then going to the left hand side. This is now what you call recharging. Now you are restoring the reactants here. You are restoring the reactants, and therefore that is called the recharging process. So a car battery normally consists of normal gas consists of six cells, whereby each cell gives us two volts. Each cell gives us 2 volts. But if you have cars which are using maybe 24 volts, like heavy commercials and the others, the cells actually, but the cell here should be giving us a maximum of 2 volts. Summation of 6 gives us 12 volts. That's why we are saying that we have that giving us 12 volts. Now, this marks the end of that. But I'll do during our free time. Try to understand the diagram and try to understand the components of each one of them. So you can actually set some questions for yourself. What is the component, for example, dry cell? What is the component of zinc? What is the component of ammonium chloride? What is the component of manganese oxide? So you should be able to know that. Then also you should be able to draw the diagram, because sometimes you are given to name the parts of dry cell, for example. Then you should be able to write the equation at the positive terminal and negative terminal, recharging and discharging equation on the lead acid accumulator. That marks the end of our lesson. Thank you and welcome.